Good morning, students. We were discussing about chapter called metals and non-metals. So already we discussed about some of the important concepts in metals and non-metals. We discussed about first concept. We discussed about the what are the physical properties of metals and non-metals. And also we discussed about the how does metal reacts with the air, water, acids, and how does metal react with non-metals. We discussed about the what are ionic compounds and formation of ionic compounds with NaCl and MgCl2. In the last class, we discussed about the reactivity series. So this is the reactivity series, that is the elements. So potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, gold and silver. Okay, so this is the reactivity series. So today we are going to discuss about the occurrence of metal. Today we are going to discuss about the occurrence of metal. So here, occurrence of metal. How does metal occur? So most of the metals are occur as a ore from the earth crust. So all the metals are ore. All the ores are metals, but all the metals are not ores. So here, and also this metal, I told you occurrence of metal. Metals are occur as a ore in the earth crust. How does this ore occur in the earth crust? Here, some of the ores or metals are occur in the free state as well as in a combined state. So, occurrence of metal, metals are occur in the earth crust as a metal or in the form of ore. This metal or ore occur in the free state as well as in the combined state. So how we are going to extract the metals or ore occur in the combined state or pure state. Here there is a method. By this method we can separate the extraction or extraction of metals by this method. So here in the based on the reactivity series, we are going to extract the metals. For example, I told you here these are all highly reactive metals. From here these are middle reactivity metals, and lastly at the bottom there are low reactivity series. So here is a table. By this method we are going to extract the metals. Here first we are going to get the ore. Ore is a minerals that is found in the earth crust. Ore is a mineral that is we are going to get from the earth crust. Here, first one, suppose we are going to get a ore. The ore is going to be concentrated. What is the meaning of concentrated? Just you know that we are going to get the ore in the earth crust. Along with the ore, there are so many impurities are present in the ore. First, we have to remove the impurities. So that the impurities that are called gangue. One more question: what are gangues? The impurities present along with the ore particles are called gangue. Which are that ore particle? Which are that gangue particle? It may be a sand, clay, or dust particle that is present along with the ore. So next, here after the concentration of ore, first here it is going to be classified into metals of high reactivity. These metals of high reactivity metals are extracted by electrolysis of molten ore, and then the metal is going to be purified. Then here metals of middle reactivity elements can be extracted by a process called the calcination and roasting. So here calcination means here carbonate ore. Suppose if you are going to get the carbonate ore, we have to use a process called calcination. Then suppose if you are going to get the sulfide ore, we have to use a method called roasting. After this, either calcination or roasting, we have to next process the oxide of metal. Then that means we have to remove we are going to get the metal in the form of oxide. By reducing the ore, we can remove the oxide. And then finally, purification of metals. And what about this metal of low reactivity? So metals of low reactivity metals are always, they are sulfide ores. You know that suppose it is sulfide ore, we have to do the roasting and metals, and then it is going to be refined. So these are the three methods of extracting the different ores. Depend upon the reactivity of that metal, we are going to classify this. Let us study one by one in detail about this, how we are going to extract the low reactivity metal series. So first one, example they given, low reactivity metal. So for example, here Hg. Hg is the example for low reactivity series. Then mercury. Mercury is a low reactivity series metal. How we are going to extract this mercury? So we are not going to get the mercury in the earth crust. We are going to get the mercury in the form of ore. So that is mercuric oxide. For example, the ore of mercury is a cinnabar. Cinnabar, the mercury, the ore of the mercury is the cinnabar. The formula for cinnabar is the HgS. So from HgS, we are going to extract the Hg. That is, from cinnabar, we are going to extract the metal, that is the mercury. How we are going to extract the mercury from cinnabar? Here, this low reactivity series can be extracted by just heating alone. Just we have to eat this cinnabar. So after eating, it is going to decompose us into mercuric oxide and sulfur dioxide. So here, how we are going to extract this cinnabar, from cinnabar, the mercury here, HgS. Cinnabar is going to be heated. It is going to be heated. By heating, it is going to decompose into HgO plus SO2. So here HgO, mercuric oxide, along with that there is a production of or liberation of sulfur dioxide. We need mercury, not mercuric oxide. So we have to remove this O, that is mercury. From mercuric oxide, we are going to get this mercury. So here, balance the equation. Hg, yes. O is 3 here. So here, for heating, we have to use oxygen. So HgS plus O2 give rise to HgO plus SO2. Hg, yes. Here O is 2, here O is 3. So to balance that, I am going to use 3 here. 3 2s are 6. Then here I am going to use 2. So O, 2 2s are 4, 1 5. So I will put another 2 here. So here 2. 2Hg, 2S, O. 3 2s are 6, here 2O, and here 2 2s are 4, totally it is going to become 6O. And then after take this HgO is going to be reduced. HgO is going to be reduced. It is going to be reduced by heating It is going to become Hg plus O2. Finally, we are going to get the Hg. So this is a method we are going to use for low reactivity series. Low reactivity series. Usually this low reactivity series metals are unreactive. They are unreactive. So this low reactivity series example, mercury is example. The ore of mercury is cinnabar. The formula for cinnabar is Hg. S is the formula for this cinnabar. So this unreactive metal can be extracted just by heating. After, suppose here, mercury, that is cinnabar is going to be heated in the presence of oxygen, we are going to get the mercuric oxide and sulfur dioxide. Sulfur dioxide is liberated. And then this HgO is heated and it is going to be give the mercury plus oxygen. So this is the method of extracting the low reactivity series. Next, after completing this HGS low reactivity series, next we are going to know about how we are going to extract the medium reactivity metals. So here medium reactivity metals we are going to get in the two forms. That is, one, it may be a carbonate ore or it may be a sulfide ore. Already I told you, suppose it is a sulfide ore, we have to use a method called calcination. Suppose it is a sulfide ore, we have to use the method called roasting. Then, what is meant by this calcination and what is meant by this roasting? It's a very, very important question. Then in the examination, they are going to ask, right, the differences between the calcination and roasting. So here, what is meant by this calcination? Calcination means carbonate ores are heated in the absence of air or limited supply of air. This process is called calcination. What is calcination? Carbonate ores are heated just below the melting point in the limited supply of air or oxygen or absence of oxygen is called calcination. Then, like that, what is roasting? Roasting, the process in which sulfide ore is heated in the presence of or excess of air is called roasting. By these two methods, we are going to extract the medium reactivity series metal. Here, for example, let us take one example. First one, suppose it is a sulfide ore. Sulfide ore, first one. Here also sulfide ore. For example, we are going to take a ore. First one, we are going to take one example, that is chalcocite. Example, chalcocite. The formula for chalcocite is the Cu2. Cu2. Yes. Here, S means sulfide. So we have to do the roasting. Here, Cu2, Cu2, yes, is going to be use the method roasting. Roasting means, I told you, in the presence of oxygen. So here we are going to heated the Cu2, yes, chalcocite in the presence of oxygen. We are going to get a compound, that is Cu. We are going to get a compound Cu2O plus we are going to get SO2. So here also we are going to extract the copper. Here copper oxide is present. So here from this the product what we are going to get is copper oxide. Once again we are going to take the copper oxide plus Cu2. Yes. So here we are going to get Cu by reduction. We are going to get Cu Cu plus, here we are going to get SO2, Cu plus SO2. So here we are discussing about the metals of medium reactivity. So for example, we have taken the sulfide ore. The sulfide ore is the copper. Chaco site is the example for this sulfide ore, the Cu2S. This is going to be done by a method called roasting. That means in the presence of oxygen, we are going to heat this ore. We are going to get copper oxide plus sulfur dioxide. So after taking this copper oxide, it is going to be once again heated with this Chaco site. We are going to get the copper plus sulfur dioxide. So finally, we are going to get this copper. So this is one method for the roasting. Let us take another example for this calcination. So calcination means it should be a carbonate ore. It should be a carbonate ore. Let us take example. That is a example for carbonate ore is the zinc blend. Zinc blend is example. Zn CO3. Zinc blend is the example. Here also we are going to take the carbonate ore. Calcination, I told you, as a calcination is a process in which carbonate ores are heated in the absence of oxygen. This ZnCO3 ZnCO3 is going to be heated in the absence of air. We are going to get ZnO plus CO2. So we need Zn only, Zn. So for that we are going to reduce Zn plus O2. So this is the another method. Finally, we are going to get the zinc. This method is a calcination. So here another, I have taken one example for the sulfide ore, another example for carbonate ore. This is zinc blend. Zinc blend is example for this calcination. Carbonate ore. This carbonate ore is going to be heated in the absence of oxygen. It is going to give this zinc oxide plus carbon dioxide. After taking this zinc oxide is going to be reduced. Then we are going to get this zinc. This is another example for this calcination. So here in this metal of medium reactivity metals, here we are going to use reducing agent. Here there is a reduction of metal. Here we are going to use coke as a reducing agent. For we are going to get here oxide of metal. Here oxide of metal is there. To get the metal, we have to reduce with the coke. So by reducing with the coke, finally we are going to get a metal. So this is about the metals of medium reactivity. Then lastly, finally, we are going to discuss about the metals of highly reactivity series. So this cannot be, metals of high reactivity element cannot be extracted by using the carbon reduction of carbon, because these are highly reactive metals. So we have to extract it by the method called electrolysis of molten ore. Electrolysis, by using electricity, we are going to get the highly reactivity metals. So and then we are going to get after electrolysis of molten ore, we are going to get the pure metal. So that is called a purification of metal. Some of the metal like copper, gold, it is going to be used. They can be purified by a method called electrolytic refining of copper or gold. In our book, they given electrolysis, electrolytic refining of copper. Let us take example for a state board. This is a diagram. There is a diagram that is for exam. So this is the diagram. The name of the diagram is electrolytic refining of copper. Electrolytic refining of copper. So for that, we have to take a tank. So in the tank, there should be a thick copper plate. Another one, we have to take thin copper plate. So this thin copper plate and thick copper plate are going to be connected. So here, the thin copper plate is connected to cathode. The thick copper plate is going to be connected for anode. So, but in our book, they given both the electrodes in the same size. So, this is a thing. So, here, this is a electrolyte. Here, we are going to use the electrolyte that is called CuSO4, acidified copper sulfate. So, here, the impure thick, this thick copper plate is a impure copper plate. This is a pure copper plate. So this is a setup of this diagram. For example, when you are going to pass the electricity here, the thick copper plate, thick impure copper plate is going to dissolve and the pure copper is going to be deposited here. And the impurities are going to be settled at the bottom. So this is called anode mud. So here, refining of copper. How we are going to refine the copper? After getting the copper, we are going to refining it. Once again, we are going to purify the copper by using this electrolytic refining of a method called electrolytic refining of copper. For this, we have to take two. One impure copper plate, another is the pure copper plate. The impure copper plate is going to be connected to the anode and pure copper plate is connected to the cathode. Here we are going to take a solution called the copper sulfate. So this is a electrolyte. Electrolyte means these are the liquids or substances that are going to pass the electricity through them. So these are liquids that are going to be pass the electricity through them. So from here, the dissolved, from cathode or anode, the electricity is going to pass from here to here and it is going to dissolve by using this copper sulfate and deposited on the cathode. So this is a pure copper plate. So first in the beginning, it is a impure copper plate. After passing this, the size is going to be reduced and there will increase the size of a cathode. So this is a electrolytic refining of copper. So after this refining of copper, there is a concept called corrosion. In the first chapter itself, you have discussed about this corrosion. What are corrosions? So, in the first chapter, the substances which are attacked by acids or moisture is said to be corrosion. Here, in this corrosion, we are going to discuss about three things. First one, we are going to discuss about the silver, silver, silver. The another one, copper. Then another one, iron. Here, how we are going to, what happens, how the corrosion take place in silver. So usually the silver after using the silver is going to become black in color, black in color. This copper is going to be green in color, and then iron is going to become brown in color. Why? The silver is going to be black, then copper is going to become green in color, and then iron is going to become brown in color. Here, for example, the silver is going to become black because this silver reacts with the air. In the air, there is a presence of sulfur. This silver reacts with sulfur and it is going to become silver sulfide. Silver is going to become silver sulfide, that gives the black color. So in the examination they are going to ask why silver is going to become black in color. Why silver is going to become black in color? Because this silver reacts with the component of air. That is, so in the air there is the presence of sulfur. Silver reacts with the sulfur and it is going to form a compound called silver sulfide. And then another example, copper. Why copper is going to become green color? This copper reacts with the carbon dioxide that is present in the air and it is going to form a compound called copper carbonate. So that gives a green color. Then iron. Why the iron is going to become brown in color? So we are going to call it as a rusting of iron. Here, for example, in our book they given the example or activity for the iron. Here, for iron, in our book they given 3 test tubes. In our book they given 3 test tubes. So in the 3 test tubes, in the first test tube, they put water and the nail, awfully immersed nail. In the second test tube, the water, fully immersed nail with the oil. And here, there is no water, they put only the nail. So out of these 3 test tubes, in which test tube does the nail is going to rust? So here, in the first test tube, the nail is going to be rust faster because for rusting of iron, it required the air and water. Suppose if there is a presence of both air and water, then easily the rust is going to be take place. And then the formula for rust is Fe2O3 2H2O is the formula for rust. So these are 3 give reasons definitely you are going to get in the examination. Why silver is going to become black in color, or copper, why copper is going to become green color, and why iron is going to become a flaky brown, we are going to call that brown in color. So for silver reacts with the air, that is especially with this sulfur, and it is going to form a silver sulfide. Then copper become green because it reacts with the carbon dioxide and it is going to form a copper carbonate. Then iron reacts with the air and water and it is going to form a brown in color that we are going to call as a rusting of iron. So this is about the corrosion. These are 3 things you have to remember about the corrosion. and definition of corrosion. Next, how do we prevent the corrosion? So there are so many methods to prevent the corrosion. There are so many methods to prevent the corrosion. There are so many methods to prevent the corrosion. Here, generally, we can prevent the corrosion by painting or oiling, greasing. Then, very important one, alloy. Make them into alloy. So, we can prevent the corrosion by galvanizing method. There are so many methods are there to prevent the corrosion. So, especially generally we are going to do the painting to prevent the rusting of iron. Then or oiling or greasing or alloying. So, by this method, we can prevent the corrosion. Out of this, in our book, they given a alloy. What is meant by alloy? What are alloys? Alloy means these are homogeneous mixture of two or more metals. Metal with a metal or a metal with a non-metal. So this is called the alloy. What are alloy? Alloy means homogeneous mixture of two or more metals. The metal with a metal or a metal with a non-metal. So that are called alloys. For example, there are so many examples are given in the book. That is the first one, stainless steel. This example, stainless steel. So this stainless steel is example for the alloy. Then brass, bronze. So these are all examples for the alloy. So alloy means homogeneous mixture of two or more metal with a metal or a metal with a non-metal. For example, stainless steel. Generally, we are going to use this stainless steel as a utensils or in the surgical instruments all are made up of this stainless steel. So here we are going to make this stainless steel. We have to use the iron. We have to add iron. Iron, along with the iron, we are going to use chromium. We are going to use the chromium, iron, chromium, nickel and carbon. So by adding all this, we are going to get this stainless steel. So another example they given about solder. Solder. Here there is one given, they are going to ask why solder are going to use in the jointing or connecting of electrical appliances. Solder, because of the low melting point. The solder is alloy. So the melting point is very low. Melting point is very low. So this solder is going to be used in the connecting the or soldering. For soldering the electrical joints, we are going to use this solder. So these are the examples for these alloys. What are alloys? Examples. These are the 4 examples they are given in your book. Examples. So this is about the chapter called metals and non-metals.